We start off, how many of you know that Professor Aniruddhan has been here on campus since a very long time? Okay. So, this is our first question.
Yes.
How was your childhood? What has changed in IIT?
Okay. So,
I repeat the question. How was your childhood at IIT Madras? And what has changed in IIT from your childhood?
okay.
It's not audible.
If the mic is available, you can use it.
So you go ahead.
Okay. Yeah. I normally don't require a mic. I think you will be able to hear me quite well. In fact, the next class will also be able to hear me. Okay. Now there is a small story in connection with that, and I'll tell you about that as well. In the answer to this particular question. So, for those of you who don't know, I actually grew up on this campus. Okay, right from childhood. Went to school in Kendriya Vidyalaya for 12 years. AKG and UKG in Manwani. First to 12th standard in KVIIT. Okay, and then after that I joined IIT. Okay, so 4 years, met few years, and then after that I'm back here again. So probably by now 2/3 of my life, or almost 3/4 of my life, I've been here. Just to tell you, right, on campus. Actually 3/4, right, more than 3/4. My father was a faculty member here in IITM. In fact, in this very same department. Okay, so he used to be in the measurements and instrumentation group. Okay, now it's the instrumentation group, right? In those days, measurements, electrical and electronic measurement was a big research area, and instrumentation as well. So he used to be in the group where Professor Jagadish Kumar, Professor Bobby George, Professor Mohan Shankar, and I think Professor Jairaj Joseph. They are the core team right now. And Professor Shivananju as well has joined a couple of years ago. There are 5 faculty. So he used to work here. So I grew up on campus. That should answer some of the follow-up questions as well. Okay, but we will come to that. So anyway, my father also has a pretty far-reaching voice. In fact, one of the professors, when I was a student, one of the professors asked in the first class, he said, "Are the people at the back able to hear me?" And then he said, "You should be able to, because only my father's name is Professor Sankaran." He said only Professor Sankaran's voice is louder than mine. Okay, so just to tell you, so I have somehow inherited that loud voice, and I hope all of you are able to hear me all the way through. Obviously I grew up, on this campus several decades ago, right? Obviously, I would say there are a lot of very apparent changes, right, and not so apparent changes as well on campus. The campus was a lot smaller. Okay, I can tell you, not in terms of area, in terms of people. Okay, lot smaller. The total number of faculty was only about 1/3 of what we have now. The total number of students was even smaller. Okay, so you can imagine how small it was. In terms of both undergrad and grad student population was very small. Life growing up on campus was like, obviously, as you might imagine, it's a highly protected place in many ways. You are not exposed to the hustle and bustle of the city. No traffic, no loud sounds, nothing, right? And surrounded by greenery. And we had every facility that was available outside, and some facilities that were not available outside as well, right? For example, easy access to tennis courts, swimming pools, basketball courts, school playgrounds for cricket, stadium for running and playing, unimaginable, right? The only other swimming pool in Chennai, when I was very small, there were probably 2 or 3 swimming pools in the whole of Chennai. Okay, now, every 5-star hotel has its own swimming pool, you can probably rent it, right? But at that time, there was just 1 or 2 places, for example. Okay, that's an example of the kind of facilities we grew up with. Now, one interesting thing is, there are a lot more high-rise buildings now. If you look at all the older buildings, they're all maximum of 2 floors, right? Sprawling buildings, 2 floors. Now, obviously, you have more people. It's growing up, vertically. The amount of greenery is a lot more now. You would be surprised. Okay? Over the years, the amount of greenery has increased, not decreased. Most of you may not know this. You may think that because all this construction is going on, the greenery is, being destroyed. In fact, when I have looked at the earliest photos of IITM, okay, GC and all was open space, barren, no trees. So the first generation of people actually planted a lot of trees. By the time I grew up, I had big trees. Now I see a lot of those trees have also been covered by secondary vegetation. All the small trees have become big trees. All the big trees have been covered by creepers and things like that. It's definitely a lot greener. There is just no doubt about it in my mind. You talk to there are several other professors on campus who grew up, whose parents are faculty who grew up here. They also, I have talked to them about this, they say the same thing. Okay, so, but apart from that, as you might imagine, my childhood was completely carefree, right? My parents had the philosophy that, don't disturb them till they get to high school. And that worked very well for me in terms of my personality and everything. So, things I would say was very happy growing up. We had all the facilities to play, to swim, whatever you want to do. And it's very safe, right? My parents were not worried if we were out till 8 o'clock, 8:30, 9. They were really not worried. So, very happy childhood growing up is what I would say.
Okay. So, were you interested in science from the start?
Yes, I was.
Firstly, ask the question.
Yes.
What was your driving force for pursuing a career in engineering? What was your favorite subject in school?
Okay. Well, my favorite subject in school was biology. Okay, it still is one of my most favorite subjects. I know you might find it surprising. It really was my favorite subject. The real problem is I couldn't draw very well, right? So you imagine going for either biology or medicine or something like that as a career. You are in those days. Nowadays you have pictures, you have e-drawings and so on. In those days, the assumption was you better be able to draw, otherwise you're going to be in trouble. Imagine you are studying medicine, you need to draw the anatomy of an organ. Right? If you are not good at drawing, right? So that was the biggest, I would say, downside of my ability. Otherwise, the chances are, more than even that I would have chosen, a career in probably medicine, if not for that biology, right? That's probably what I would say. Now, all of you know this concept of ikigai, right? Now that's very big now. This Japanese concept of ikigai is to put together, it's a Venn diagram of multiple things. What you do, you should be interested in, it should be useful to society, and so on, right? So if you think about it, I would say electrical engineering science is my ikigai, right? It is not necessarily my top thing to study, but definitely, I was pretty good at maths and science, right? I liked it. I liked both maths and science. It's not that I disliked them, I liked them. I was pretty good at it. And, obviously engineering is fairly useful, there were no downsides, right? And electrical engineering requires lesser engineering drawing than other areas of engineering. That also worked out. That also worked. Okay?
Right. Okay. So now today we have a lot many number of freshers here.
Bro, can you just talk more loudly?
We have a lot of freshers here, and the biggest question they have to ask is, what drove you towards choosing electrical engineering at IIT?
Okay. So,
was this out of your JM?
okay, good question. So, see, there are a bunch of things that drove it. Subconsciously, I would say, with my father being an EE professor, you might imagine that I heard a lot of talk about EE, right? Naturally. And it's so I'm the youngest of three brothers. I have two elder brothers. They are both also electrical engineers, and they also graduated from EE department of IITM. You can imagine, right? It's like a dolphin swimming behind a boat. You are sucked in whether you want to or not, right? But I would say, because of this, the way I would think of it, I was exposed to a lot of electrical engineering. The way I would think of it, see, if you are an electrical engineer, you are going to talk about all the positives, all the great things of electrical engineering. And when you want to teach somebody to swim, you'll be talking about how important it is to have the skill and how fun it is and so on. When they start swimming, it's hard work for long periods of time, right? So that's when they learn. But then after they learn that skill, they are very happy. That is the way I would say my choice of EE is. There was a lot of subconscious stuff that I picked up at home. And also, I would say, but this I feel comfortable talking about because, see, for example, people of that generation, my father's generation, when they were studying, computer science was not a big thing, for example. Okay, so software was not particularly very highly sought after. I mean, it was highly sought after, but not seen. Hardware work or applied engineering was seen as better in the previous generation of teachers. I probably imbibed some of that because I interacted with people. My father, built electrical and electronic circuits, hardware for a living, his research. And that kind of, I'm sure I picked it up subconsciously, right? Thinking that, I need to do something with my hands. I need to do something, build something that works and be able to see it, rather than like build a model, do some theory, something like that, which all have their place in every branch of science and engineering. So I would say it's a little bit of everything. Even at that age, I had understood from talking to people that electrical engineering was extremely broad. Okay, it's one of the broadest areas of engineering, right? So I was the third batch of EE. So 3 years before I joined, they had ECE and EEE. I think ECE and EEE in that avatar. Before that, they called it high power and low power, high current, low current. All these names are all from 50, 70 years ago. Before I studied, it was EEE and ECE. 3 years before me, they kind of decided, we need to combine and offer a single degree. And now coming to the JEE rank, so one of the things I would, since you asked as part of the question, see, I would say at this stage my JEE rank, and you talk to anybody who's 20 years into their career, things like JEE rank, CGPA, undergrad, these are all things that won't matter at all. In fact, 5 years from now, I'm telling you, none of these things would matter, okay, to you even. Because you are going to build on bigger and better things that will be more valuable to you, more valuable to society, more valuable to a company. This will all be a distant memory, right? In terms of the quantitative way of evaluating you. That's what I would say. Okay. So what I will say, since you asked the question, I was somewhere in the middle of in terms of my JEE rank. Okay. I was not at the upper end of the JEE cutoff on computer science and EE where there was some overlap. And on the lower side, it was like computer science and electrical engineering, mechanical engineering. I was very close to the middle in terms of my JEE. That much I'll say. I don't want to give out my JEE rank and bias your minds into thinking that it's more important than it is. Okay.
I'll go with the next question. I'll use the exact term. How did it feel back in the day at IITM sitting in a class of extremely motivated and intelligent people, all passionate about the same dream, a career in technology? How many people were there in your class at IITM?
Okay. So I'll start with the last one first because it sets the idea of what our classes used to be. So the total incoming strength was about 360. Okay, undergrad, BTech. There were fewer branches as well. EE had, I think in my year, 78 students. That's what it was, the second largest. Mechanical had some 82 or 83. EE was second largest. Our graduating class was about 78 students. So about half of the typical batch size now. Okay, and for many courses, that 78 batch was split up into 2 batches to teach them, because you can imagine that people had very strong opinions on how big the class size should be in those days, just as they are now, right? Today you don't have choice of having like 5 different sections. You may be 180 people, but I can't create 5 sections of 30, right? But in those days, 78, 2 batches of 40 each approximately, right? That's what kind of, as much as possible, they try to do that. And I think the first part of the question is interesting because I'm not sure how many of you feel that all of your classmates are motivated and high achieving and want to stay in science and engineering and electrical engineering in particular. But I can tell you one thing. Among my batches, it was not so, I mean, the background of the students was very similar, right? you had people who had done well from all parts of India. They probably didn't have much idea about electrical engineering. They chose it based on the JEE rank, probably the same as now. They came in. I'm sure several of them did not like it beyond a certain point. They liked it, but maybe that's not what they wanted to study. I'm sure there were people like that. I'm sure there were people, who really learned to love it, right? It was a fairly diverse group. That's what I would say. Okay, just like now, students at the age of 17 having to choose, or 18 having to choose a branch of engineering that they know nothing about, in my opinion, is not a great idea, right? Unfortunately, there are no easy answers, right? There are no easy answers to the question, so right now, status quo. Okay. Now, one thing I would say, as the last kind of summary of my answer to this question, a good number of my classmates are still in electrical engineering. Okay, they are still doing electrical engineering, core electrical engineering of various sorts. And that was because I would say the communications boom of the 2000 to 2015, and even now we are seeing the last remnants of the real boom, right? We kind of hit it right at the beginning, right as it was, increasing exponentially. Okay, made a big difference. So most of those people are still doing electrical engineering of some kind. That much I would say. There were always people who went to management. There were people who went to, they do business now. I have a couple of classmates who do business. I have a few classmates who do, other things, right? They've not decided not to work, maybe volunteer, do something. It's a wide variety, right? And I think you will see that as well. Okay. The difference is that you have a lot more opportunity now compared to what we had 23 years ago, 24 years ago.
Right. Adding to that question, Amit, now you see some of your colleagues are seniors, juniors. How is the interaction different now from them?
So surprisingly, I don't think there is any of my immediate seniors or juniors at IIT. Plus or minus 3 years, I don't think there's plus or minus 2 years, definitely nobody. Plus or minus 3 years, I don't think so. I think Professor Radhakrishna Ganti passed out in 2003, if I'm not mistaken, but I didn't know him, right? And I'm pretty sure he didn't know me. So, my colleagues who did their undergrad at IITM, I didn't know them. I knew some of them because of the circuits community. I knew some of them because of other reasons, but not because I knew them at IIT. Okay, that much I can tell you. So the question of whether it was different, I can't answer. Okay, what I can tell you, I don't know if it's coming up in future questions. What I can tell you is several people who taught me are still around. Okay, that much I can tell you. My professors are here, many of them. Many of them. Okay,
Can you name a few?
Oh, that was the next question? Okay. So, among the people who are here, right, I can even tell you what course they taught me, by the way. And some of the courses are quite different. If I remember right, the first course for us was electrical magnetic circuits. That was taught by Professor Jagdish Kumar. Then signals and, in those days, signals and systems was called networks and systems, because it was applied to, in that course, to networks, electrical networks. Okay, that was taught by Professor Bhaskar Ramurthy and Professor Jalihal, Professor Devendra Jalihal. Then we had principles of communication. That course does not exist now, and that was taught by Professor Jalihal and Professor Aravind. Okay. Then I'm telling you, among the professors who taught us, who are still faculty here, Professor Karmalkar taught us solid state devices. Professor Amitav Dasgupta and Nandita Dasgupta taught me the introduction to digital systems. Okay. Professor Ashok Jhunjhunwala taught me communication systems. Professor Sarathi taught us a course on high voltage engineering. Okay. And let me see. The other professors, I don't. Professor Inakshi Bhattacharya was my faculty advisor. Okay. I think I have covered more. Professor Giridhar taught communications. So in those days, he taught. So there used to be a course called analog communication, which is your probability, and then digital communication, right? which I assume had to do with modulation and so on. So we had a grand total of probably 5 electives in our whole BTech. You can imagine how different our experience was compared to yours. Okay, very different. In our, I think, 6th semester, we had to choose our first elective, and in the same slot, you would be offered analog IC design, which is your first analog circuit elective. You would be offered analog communication and device modeling in the same slot. So you choose it and you are done for life. That's the idea, right? You choose circuits, the chances of you coming back at the undergrad level are very low. You take it in your 8th term, you don't take any other further courses. Okay, it was like that. Okay, and Professor Giridhar taught, I think, if I remember right, the digital communications course. But I had already chosen the circuit stream. And there is an excellent professor on analog called Professor Radhakrishna Rao, who taught us analog IC design. And I took that course and follow-up courses in circuits. And then, by the way, there are no more follow-up courses in circuits because there are only 2 professors in circuits. Okay, and then there was also active filter design, which I did take. Okay, but I wanted to go in the in a different direction. So, but the number of electives in each stream was very small. Right, that's what I want to say. So, future questions. Okay. Anyway, you can ask that and I'll maybe expand upon it a little bit. But I think I've listed out every professor who has taught me at IITM currently. I think. Okay.
Did any of the students?
Did any of?
Your students.
My students come back. Not yet. It's too. I'm not that old. Okay. I'm not that old. Maybe in a few years. Not now. Too soon.
I'll go with the next question. What were some of your most memorable moments during weekend? Were you a hosteler? Were you an early riser or night owl?
Okay. The last question is easy to answer. So I was not a night owl. Okay. But I was a normal. Depends on what you call early. And again, that's a little bit vague. But but one thing I will say, I used to attend every class without fail. For obvious reasons. The news will get back to my father. For obvious reasons, I would attend every class. Okay, and I was supposed to be a model student. No, see, at the end of the day, this was, with your father. Imagine your father was a teacher in school or a professor in college. This would be dinned into you right from childhood, right? About how important studying is, how important going to classes. These were all dinned into us way earlier than BTech. I can tell you, it is not something that something that he used to follow up on.
We have 2 students who are exactly the same.
Yes, I know one of them. Who's the other? Okay. Okay.
Sir, you stayed in hostel or in your home here?
So okay. Is that also one of the questions? Okay. Maybe I'll answer that now because it feeds into the experience. It is part of the same question. So what happened was it was very interesting. My father, see, we lived on campus, barely like a 10-minute cycle, 5-minute cycle right away. But my father was a very strong believer in making, I told you my brothers also studied here. He was a very strong believer in us having the hostel experience. Okay, he told all of us, you have to go and stay in the hostel. Okay, and in hindsight, absolutely that was the right thing to do, because the Indian childhood, especially 20 years ago, you may not imagine how it was 40 years ago, but 20 years ago, I can tell you when I was in college, most students who came to IIT and other places as well live a fairly sheltered life. Okay, even if you are living outside. So, independent, staying in hostel, learning to do everything by yourself, or being relatively independent. Okay. Was very important, and he knew it, and he made sure that we all got that experience. The one thing that happened was, and ragging and all used to go on. I don't know. Well, since this is being recorded, I can maybe at the end I will talk a little bit about ragging as well. But I don't know how it is now. You probably also don't want to share, right? I don't know how it is. But in those days, see, ragging was there. Okay. In a few cases, it probably was harsh. I wouldn't be surprised. But in the majority of cases, it was seen as creating a bond between the students and their seniors. And typically at IITM, it never reached the point where there was requirement for any major intervention. That is my understanding. And maybe after the session, I will talk a little bit about one or two experiences. Not for me, but what I saw as well. Because I'll tell you why. Because the ragging was relatively, this thing. My father felt that was not a big issue. Parents may think, hey, I'm sending my kid even though he could just stay here for the first year and then go out. But the problem is, it's the first year where you create the bond with your seniors and classmates. And now, one thing I know for your batches, they have fragmented branches across many hostels. That was not the case during our time. Okay? During our time, the branch, electrical engineering being a big branch, we would be split up into 2 hostels, no more. Half in 2 hostels. Smaller branches would stay in 1 hostel. Okay? Very important. I think that is something that has been, that you are losing out on the student experience. Because in many ways. Okay? So what would happen, as a common branch, we would undergo ragging by the seniors. The seniors would be a different branch. It's not that the seniors would be the same branch. Okay, they would be from chemical, mechanical, aero, whatever it is. But as a group, you would get ragged, so that's a bonding experience among you and your classmates. We used to study together for quizzes, 10, 12 large, right? Projects, whatever it is. It used to be large groups, wings or half wings would get together and study together. Definite bonding experiences. Okay? Same way with the seniors as well. It would be a bonding experience. The ragging never got to that point where it was a real problem. The one thing that happened for me was that hostels ran out of space. Okay, so the hostel admin requested my father to allow me to join hostel in the second year. So that's what happened. They did not have space. They made a request. So I did the first year, studied the first year from home. I used to hang out in the hostel. Okay. Second year onwards, I stayed in the hostel. Second year, third year, I stayed in the hostel. Fourth year, half the time. Okay. The 8th semester was the BTP. Those of you in your final year going to do your BTP, you can imagine probably BTP plus 1 course. You have a lot of free time on your hands, right? So what happened is, I slowly started transitioning out of the hostels back home. Right? So I spent much longer at home, I would say. Okay, I was in Mandakini hostel in the old avatar. Now my hostel no longer exists. Okay, in the last couple of years I stayed in room 303. Okay, it was in the, you used to enter it from the southern side when you enter the hostel. So the far end, second floor, top right side. Okay, 2 rooms away from the toilets. Okay, so yeah, so I was in Mandak, it no longer exists unfortunately. Okay.
Go to the next question.
Sure.
Did you have analog system? Once you answer this, I'll go to
Sure. No, we did not.
question.
We did not have analog systems.
Okay, 1 second, I'll continue. The formal wording of the question is like this. Analog systems is widely known throughout IITM as one of the most intense courses. In some sense, it provides a benchmarking test for an electrical engineer that every E student has to go through. Was this level of rigor prevalent during your undergrad at IIT?
Okay, very good question. So,
Is the person there?
okay, very good. So, we did not have analog systems. See, the way the analog circuits courses are structured today is for today's analog community, is for the way analog design happens in the analog community today, okay, which is focused towards IC design, okay, because anything outside that is system design, okay, and there is a place for that as well, but I would say companies like TI, even Qualcomm, analog devices, they build ICs, and that's where most circuit designers want to be, or at least wanted to be even in those days. So our courses are structured like that now. Okay. Well, specifically about analog systems as a course has been around at IITM only for about 5-6 years, not longer than that. Analog circuits used to be the core course. Okay. Because analog circuits a lot of students, had trouble, shall we say, which kind of is the thrust of the students' question. We introduced analog systems. It didn't solve a lot, right? It didn't solve a lot of the issues, right? And but when we studied, we had 2 compulsory analog courses. Okay, it was called Principles of Electronics and Electronic Circuits. We had 2 courses. Exactly, you imagine that you put together components of analog systems and analog circuits and a little bit of analog ICs, plus some stuff that we don't teach you right now, okay, which are taught in other courses. Okay, that is the content of those 2 courses. Broadly the same, no MOSFETs, only BJTs. The grand goal at the end was to understand, analyze a BJT general purpose op amp, which had a, there is a classic op amp called the 741. Okay, did you use it in any of the labs? You did. Some lab you have used it, or some of you might have used it.
EP lab.
Huh?
EP lab.
EP lab. It's a general purpose op amp, excellent general purpose op amp. Unlike your MOSFET op amps, which many of you study now, which have 6, 7, 8 transistors, that has about much more, many more. Okay, probably 30, 40 transistors, and each one of them, it's a general purpose op amp, so each one has a certain function. And now answering that second question, absolutely, analog circuits, principles of electronics and electronic circuits was in fact much more infamous in those days compared to today. It was much more tough compared to analog systems today. So I would say things are actually easier for you folks. Okay, because imagine doing 2 compulsory courses. First of all, imagine studying more, many more details, okay, of these kinds of circuits, and to put it together, there is a imagine there is a requirement which still exists today, to get the answer down right to the, let's say, first or second decimal place, right, correctly. That still used to exist. Okay, so it was probably the toughest course. Okay, I don't know if in your opinion it still is. It was definitely the toughest course. Okay, in the undergrad. That I would say.
Moving forward, were you involved in any extracurricular activities?
Okay, so not majorly. Okay, not majorly. I did NSO badminton in those days. Okay, for the compulsory NSO. But specific extracurricular activities, no. See, already the number of extracurricular activities are were much fewer than those today. Okay, we did not have E2A in a very active form. We did not have these sci-fi club, things like that. We did not have these competitions, so on. But obviously, I used to take part, the classic games in Sarang, for example, quiz, general quiz, just a minute jam, Dumsy. Damsharaj, does it still go on in this thing in some form? It does, right? So those were all things that we used to play. And I used to take part in during Sarang or the ISTI, quizzing, competitions, etc. Those were all stuff. Apart from that, the general extracurricular activities were, we used to, because we were a full, half the branch in one hostel, we used to hang around a lot in the hostels. Okay, the hostel has this big quadrangle area, right, in the middle. We used to play football, volleyball, everything, right, in that area. Nights were spent, playing music, chatting, playing cards sometimes, the usual things. We didn't have, computers, we didn't have phones, we didn't have any of that. There used to be one computer room in the whole hostel. There used to be, of course, one TV room. If there's a cricket match, that's it, right? Obviously, the whole hostel would be in that room. But yeah, apart from that, I don't believe I was involved in any specific extracurricular activities at IIT.
Now we'll move into something technical.
Okay.
Why research?
Oh, okay. Why did I choose research?
What was your primary motivation?
Okay. So I would say the idea of research in my mind okay, is there are several aspects. A couple of aspects stand out for me personally. One of them is definitely doing something on your own independently. Okay, so you do undergrad projects, you do even MTech projects, you are guided a lot. But PhD or Masters by Research or PhD is the first time you are going to be let loose to think, do something by yourself. The idea of research is that even your research guide does not know the answer to the question that that you are trying to answer. So nobody knows in some fashion to the level of detail that is required. So that aspect of it definitely attracted me. Okay, the aspect that you have time to think was great for me because I was not very good at doing things very fast. In exams, I used to run out of time. Okay, so the aspect where I had time to think and implement and do attracted me. Okay. Third thing, I would say very early on, during my undergrad, probably in my third year or final year, right? I was pretty sure that I wanted to teach. I was pretty sure that I wanted to do a PhD. I was pretty sure I wanted to teach. In fact, I was pretty sure I wanted to come back here and teach in IIT. Okay, I had already planned out to that extent. Okay, if you can imagine. So, so research was a given, right? So these two aspects, I would say, independent thinking, independent working, and finding out something that nobody else has done before. These two aspects, kind of drove me in research.
Okay. Adding to that one, students
Little
are often
bit
scared.
louder.
Students are often scared about not finding their passion. How did you go about pursuing yours, and what advice would you give to current students?
Okay, so I would say there are actually a lot more opportunities today, right, in finding, but that comes with a downside as well, right? If you have too many options, then it's hard to choose, right? So I would say I talked about Ikigai, right? Finding out what you're good at, what you like. You need to come to a happy, centric way of living, centralized or centric way of, what you want to do in life, right? Some people are lucky, they get exactly what they want, everything goes right for them. That may not happen to everybody. That's what I'm saying, okay? And what I would say is, I really like circuit design. So see, there are certain aspects of circuit design that, I was immediately drawn. It was various things, right? There is opportunity to build hardware and test it and see that it works. So I was pretty sure in my mind that I wanted to do something, build something, make it work and prove it, right? So I was not very good at coding, okay? By the way, coding was not very big also in those days, right? To tell you, our first course, C and C++ were very popular, but somehow the computer science department decided to teach us Pascal. I don't know how many of you know of a language called Pascal. Even in those days, it was obvious that Pascal was an old language, but they decided to teach us. So you can imagine that how it would have turned me away as well. I was already not very good, right? And it was like, hey, this is not for me, right? And it was, for me, I was very happy that I actually found circuit design, and I was very lucky that it worked. Okay, it worked for me. As I went further into circuit design, I liked it even more. So it really worked out, right? And I was actually surprised. I mean, not surprised. I was actually lucky that I actually found a niche area, high frequency IC design, that actually I like. I am, decently good at, that I enjoy doing, and hopefully there are enough other people who enjoy doing it as well, right? So that also matters.
Next
Right?
question, probably you have already answered. Why did you choose analog electronics as a career path? In particular, what motivated you to pursue it?
Okay,
Half is done.
half is done. So what I will say is, I told you that we had an elective on analog IC design, Professor Radhakrishna Rao. I really, enjoyed his course. Okay, loved it, and that definitely spurred me on to like IC design even more. That's what I would say. Okay, and now my choosing RF, highly accidental, completely accidental in fact. Okay, because in those days I had no idea what RF meant. RFIC was in its infancy. You go back and look at how old the RFIC community is, especially in CMOS. It started in the early to mid 90s. So you are talking about something that has been in the larger research community only for like 6-7 years. Okay, it was all complete luck. Okay, so there are a couple of things that happened. The first lucky coincidence. So for my BTP, so I went and asked Professor Radhakrishna Rao. He had already said okay, yes to a few other students. So what he told me is he asked me to go and talk to another professor. Oh, by the way, I realized I had left out one of the other professors who taught me, Professor Madhyaragan. He's, I don't know if any of you have taken a course with him. Okay, he was my BTech project. I should have remembered to include him there, but I anyway remembered that I wanted to talk about it, when I asked about my BTP experience. But I will tell you that Professor Madhyaragan was my BTech project guide. And so amazingly, he told me, because he didn't teach any course, but he taught us, I did my BTP with him. What happened is that I went to him and told him I want to do my BTP, can you suggest a topic? He gave me the independence to choose a topic of my own. So he told me, why don't you go explore, come back, we'll discuss it. And then, so I went, picked up a few papers of his, picked up a few papers by other people, looked at it, and found, a topic. It was actually on ring oscillators, okay, high frequency ring oscillators at that time. And he was happy to guide me on that. I worked on it. Completely accidental, I would say. If I had come across some other paper on some, high performance ADC, some filter, something. In fact, filters was one of the topics I broached with him. He said choose something else at that time. I distinctly remember. Okay, so that kind of completely accidental. But there was one more thing. Remember, I told you. So one of my brother's classmates. I think I told you. I talked about my brothers, right? One of my brother's classmates happened to visit, IIT because he had gone for grad studies. He was doing work in RF, IC design. So he came back and told me, hey, this area is very good and there's a lot of potential. You should strongly consider pursuing. If you like something, things work out, somebody comes and says this, it's like a big boost, right? You would, as you might imagine. So I said, okay, I'll do that. And I contacted several professors doing high frequency IC design, and I was lucky enough to find my Ph.D. guide, Professor Dave Allstott. So somehow things just worked out, and I can't say the rest is history because it's not history yet, but it was kind of very fortuitous, I would say. Okay, so my choice of RFIC design, very fortuitous, but amazingly lucky that RFIC design was kind of on its upswing. The communications boom was on its upswing. Talk about right place at the right time, right? Being lucky. That's exactly what I was as far as the topic is concerned. I can assure you 100%. Okay, there was no specific thought process saying this is the thing to do. That much I would say.
Next is a very interesting question. What do you think an undergraduate has to do in his 4 years of being in life?
It's a very open-ended question. Okay. Depends on from what point of view. If the questioner is here, they can say what point of view you ask the question. Okay. Well. Okay. So there are a few things. I'll try to work as many aspects as possible into my this thing. Into this. See, I would say if you are interested in electrical engineering, being in this field, continuing in this field, one thing I would say is the number one thing that's going to matter is your courses. There is no way around it. Okay, how well you study in your undergrad is going to have a direct correlation with everything. You know, how well you do in grad school and so on. Okay, it does matter, believe me. Having said that, and of course, see, you folks are, you know, doing several much broader range of courses than we ever did. Okay, and the world is moving to a situation where there's a lot of interdisciplinary work that is going on between different sub-branches of EE as well. I would say it's all the more important. Okay. Now, having said that, there is another aspect. I do see a worrying trend from my point of view at a lot of students being overworked, not having enough time, taking on too many things. Okay. There seems to be this, the modern term is FOMO, right? Fear of missing out, right? There seems to be this FOMO mindset, okay, among many students. Definitely worrying. Okay, definitely worrying, because these are supposed to be some of the happiest days of your life. And I will tell you, the grad school will be fun too, but the minute you go to work in any form, your time is not your own one way or another. That much I can tell you. Okay, if you go to corporate, they want you to work 60, 65, 70 hours a week, right? If you join academia, you may think that you know, it's not that way, but it is that way. Okay, you know, you may think that, you know, I spend my weekends very happily, nights and weekends. Unfortunately, it's not so. Okay, the number of you know, committees, the number of responsibilities, the number of you know, work that I have to do inside, outside class, you know, yeah. So I enjoy it. I'm happy to do it. Obviously, I've chosen that, and I'm happy to do it. My point is, it keeps me busy. Okay, these are some of the last few years of your life that you're going to enjoy truly, and you should enjoy. Okay, take your time and enjoy. The idea should not be, I did this, next I do this, next I do this. The idea should not be, I have, okay, 4 years, I have 8 breaks, 4 winter, 4 summer breaks, I have to be occupied. Absolutely not. Okay, the idea of internships was highly uncommon. Actually, probably only a handful of my classmates went on internships. Okay.
That's the next part of this question.
Okay.
What's your take on internship? Corporate versus research.
Corporate versus research. See, I would say it is okay. See, in this day and age, you cannot not go on internship. It has a direct bearing on your career. Okay. But I would say you should not keep all your breaks occupied. Okay. You need that time to de-stress. Okay. Do something else. Okay, take your mind off studies. You have been, you know, 3.5 grueling months, right? Why would you not? Why would you take on more work during the break, right? You should be doing something else, anything else. It could be a hobby. It could be, you know, just having fun, right? Nothing wrong. That's what I feel you folks should do, right? Instead of keeping busy all the time. And I mean, you know, don't spend that time watching TV or OTT or whatever it is. That is bad. Or hooked onto your phone. That would be bad. It's better to go to work than do that. That much I'll tell you. But you should really find something else. That's what I would say. Okay. That is one worrying trend that I see among this generation of students when I compare it to the previous generation. Okay. See, I will be frank. We also, for many of our courses, we used to, at that age, we used to study the day before the quiz. Okay, how much ever I advise you, it is not necessarily what I myself practice or many of my classmates practice. And I will advise you what I think is good for you, not what I did. You should not be repeating my mistakes. Okay, I will be frank and confess that for many of my courses, I used to study at the last minute. You're right. You know, the day before the quiz, you know, start solving the tutorial. If somebody has a solved tutorial, you know, get fundas from him, and then come back and that's it, right? And you do group solving, okay? 5, 6 different people, and there will be one, you know, major guy. We used to, you know, the really smart guys we used to call them studs. I don't know if that is the usage now. The word stud or cat meant that super smart person. Okay, we would say that this guy is, you know, okay, let's go get fundas from him. Go get fundas, come back, try to solve the next question. That is the way it used to be, right? You should not do that. Okay, having said that, most of our evenings, weekends, nights was spent, in a fun manner. Okay, evenings we would play outside, stadium, ground, hostel. We would spend the nights chatting, play cards, or we would actually play music. There will be one guy who will have a guitar, we'll sing, play, all that stuff, right? Of course, I understand you may be thinking, hey, this guy's from the 50s, right? 1950s. It's not so. What I'm trying to tell you is that used to take our mind completely off from studies. The idea is your mind requires rest, something pleasing, calming to do. If you had told us, do a sci-fi project, do this other project, we would have been stressed out, okay, for sure. I would strongly say, chill. 100% chill, okay? When you work. Outside of that, chill. That is my biggest advice to everybody, okay? Now, like I said, internships, I am strongly against internships, filling up every break of yours. Yeah, sure, one internship, two internships, okay. Every break is just too much, right? Corporate versus research, depends on what you want, okay? If you are interested to go for higher studies, masters, PhD, or nowadays only PhD, because many masters programs in the US are no longer research based. 20 years ago they used to be. I did a masters by thesis. I built a chip, I tested it, I did that for my masters, much like our MS program right now. But nowadays a lot of MS programs in the US especially have to move to like our MTech, a masters by coursework. Primarily meant for people who are going to join the industry. Okay. If you are interested in that, right, probably an internship makes a lot of sense. A corporate internship makes sense because you have the option of, if you do well in that, you'll get hired, etc. If you want to do a PhD, you should probably do a research internship. I would strongly advise it in this day and age. You should strongly take it up. Okay. So in fact, if you want to do an internship, I would say it is perfectly fine to go to another, university and spend your summer doing something new, studying something new, doing research. That will really help you a lot. Okay, that much I can tell.
Going forward, who was your favorite professor?
Do you have a follow-up question to that as well?
Yes.
Who was the
I
not so
asked
favorite professor?
all the three questions. Who was the professor you feared the most? Do you have any interesting experience with the faculty you would like to share?
I think the answer to the first question was that a lot of my professors are still here. So I'm going to give a skip to that one. Okay, it's the second one for sure. Okay. Who was my favorite professor? I would say there were several. Probably Analog IC Design Professor Radhakrishna Rao was definitely way up there. In different ways, right? In teaching, definitely. Professor Madhyaragan, BTP, he gave me the space, the independence to work. Professor Karmalkar, for the completely systematic way in which he would develop from basic physics to device physics, I would say. Then Networks and Systems, Professor Jalihal and Professor Bhaskar Ramamurthy, excellent, right? I enjoyed all those. Professor Jagadish Kumar, he taught basic electrical science. These were some of the really favorite, teaching style, courses, BTP, all of these things are very interesting, I think so. Okay. The second one I'm going to give a pass. Okay. Not so favorite teacher.
So it's a professor who is still there in the department.
Doesn't mean that, right? Doesn't mean that. But I'm not going to talk about it. Okay. That much I will. See, I know that. See, we had a fairly wide distribution of quality of professors even in those days. Okay, that is the best I can go okay, in such a session. Okay, so I'm not going to tell you that all my professors were golden, because that cannot be the case. I think you would just call me out immediately, right?
You didn't answer the last part.
What was the last part again?
Do you have any interesting experience with any faculty?
Yes, I had several interesting experiences. I'm trying to think which should be the most. Okay, let me see. Well, maybe I'll take a pass on giving any specific experiences or specific this things. But I'll say, see, the general experience was we would obviously see the one-on-one experience. It's hard for me to say it right now on a recording, for example, because many of them were outside class, and so on. But there are a couple of experiences with professors that I can definitely share. Okay, so one of them, humanities courses we used to have, just like you folks do. We used to have a professor called Dilip Veeraraghavan. Okay, unfortunately he's no longer with us, right? And he passed away a few years ago. Excellent teacher. So he was actually he got gradually blind as I think during his maybe teens, late teens or early 20s or something like that. So my first humanities course was with him. He taught a course on history. Okay, and he used to talk extempore, right? And it was amazing. And he used to be very friendly with the students. He would chat with you about everything. Okay, literally everything. Okay? It could be about other professors. It could be about music. It could be about history, of course. It could be about your hostel life. It could be about anything. Literally, he was that open to chatting. And because I took this course, I spent a lot of time during that semester talking a lot, with him about many things. I would say that was definitely a very nice experience. Well, let me see. I'm trying to think of some maybe more specific experiences that would this thing. Yeah, I think nothing major to report. I would say that I can say right now.
So next, I think there's a question by PhD scholars. Would you recommend a master's or a PhD right after an undergraduate degree? What are the pros and cons for someone who wants to get into academia?
This is from the PhD students. If it's from the PhD students, you should do a PhD.
I hope some research.
Maybe from some research scholar. Yeah. See, this has also been asked by some of the undergrad students over the years that I have been here at IIT. And I can tell you one thing. I have advised the exact same way. Do your master's immediately. Okay? That is the single biggest advice I give about apping, about higher studies, etc. I would strongly advise that if at all possible, you do your grad studies immediately. In my experience, both in grad school and at IIT and in other places, I can tell you there are a bunch of things. The number one thing that will happen the minute you join a company, in whatever form, in general, there are 2 or 3 skills that will degrade fairly quickly. Okay? First one, your analytical skills. Here you are doing analysis every day in something or the other. Once you join a company, you will, let me assure you will not be doing it every day. Your analytical skills will degrade. In 6 months, at your age it may be a little bit longer, 1 year, 1.5 years. But I can assure you, the longer you spend, the worse it gets. Second, writing exams, timed exams. It's a skill. I think you folks know it. You folks are mature enough now to understand that you folks have been trained for the last 8 years to write exams. We were also like that. Okay, we were trained to write exams, right? Literally, both school and I don't know when do the people start preparing for JE and main advance? First standard. I hope not. I don't know the latest. So in our days, it was 11th standard. Okay, 11th standard. Most people would start. There will be some people who would start in 12th standard. Okay, and occasionally you will hear about this God guy, who didn't take any coaching, who lived in this village and who wrote JE and joined computer science. Okay, you will hear about this. I don't know how true it is, but what I'm saying is, now right from school, middle school, you are trained to write exams. And at IIT itself, you write so many exams. The minute you stop doing that, it's a skill that is perishable. Take it from me. It is a skill that is highly perishable. Okay, you will lose. If you go for your masters, you'll have to retrain yourself. Why would you do that? right? Why would you do that? Okay, so I would say from that point of view. Third, there is nothing you are going to get from any corporate job that you are going to get, you are going to find useful for your PhD or even your masters. Very little that you are going to find useful. Okay, if you spend a long enough time, there will be ancillary skills that you will learn which will be useful. But if you're going to say, hey, I'm going to app next year, okay, I'll go, I need to take my time writing GRE, I'll have some time to app, do the research and so on. That's all maybe true, okay, but you're better off apping right out of school. Okay, that much I would say. Now, finally, if you're going to do a PhD, this is all the more important, because either masters plus PhD or PhD, it's going to take like 5-6 years for sure. Okay, you don't want, there are other responsibilities that will come once you go beyond 25 of various kinds, right? That could very well impede your progress, okay, in your PhD. For some people, I'll kind of cover all bases that way. What I mean is, there were several grad students who came from Iran, China, Korea in my school. Many of them were married because they have compulsory army service. They had to do 2 years of army. They were 2 years older than us, so they were married. Some of them had kids. It's a lot to handle. Imagine you have a deadline for your PhD, deadline at home, right? Which would you choose? I think the answer is obvious, right? What is going to lose out? Your PhD? Nothing, it will take a little bit longer, okay? You are better off trying to get these things done early on, so that, nothing wrong in getting married in the final years of a PhD, that's not what I'm dissing. What I'm trying to say is that the longer you spend in school, right, when you have time, energy, focus on studies, on research, it will prove highly helpful for you. That's what I'm trying to say. So, right out of school, all these aspects, it's a no-brainer in my mind. Okay? Now, there are some certain cases where maybe you need to earn some money before applying for master. In that case, there is no question, right? You should probably do that, right? But in most cases, I would say if you're able to handle the financial side, I would say do it immediately.
That was one big future question.
Okay.
Next question is another interesting question. After investing around 5 years in Qualcomm, an extreme growth for PhD graduates, what made you switch to academia?
Okay. So, I'll say a few things. I think I told earlier that right at the time of BTech, I was kind of had a long-term plan to teach and to come back to IITM as well. And my idea was, VLSI, IC design is a highly applied field, I would say. IC design especially, highly applied field. Okay, you learn a lot when you work in a company. Okay, once you know what you're doing, okay, you learn a lot in the company. There's no doubt about it. But in any company that you learn, there are a few things that you would miss. Number one, independence of thought, independence of breadth of thought. For example, the company has a product line, there you are assigned to a particular product, assigned to a particular circuit. Why would you spend time thinking about other circuits, other systems, other things? You wouldn't, right? Whereas, as a faculty and a researcher, I can think about 5 problems, on 5 topics vicariously through my students. But what I mean is, I can do that, right? They can help me learn 5 topics. That's the way I think of it. Okay, that part was definitely missing in a company, in Qualcomm and in any company. I learned a lot. The second thing is the amount of ancillary things that you learn kind of narrows down. Okay, what happens is that you will learn a lot about things outside the IC, the process of testing, process of packaging, everything else. You do that for 2 product cycles. Nowadays, that's about 3 years, 4 years. What are you going to learn next? They're going to ask you to manage, be responsible for bigger blocks, bigger systems, and so on. Okay. That's great for some people, it was not the right thing for me. Okay, so these two aspects I would say kind of set it fairly, I would say I was, in a fairly stable form in a few years after joining. That, I'm not going to learn much more technical. Okay, you can spend a lifetime in circuit design and IC design and do a different circuit every cycle, you will not run out of circuits. That's the amazing thing. But, the independence of thought, things like that were missing in some sense. So it kind of, putting all this together, the move to an academic role made a lot of sense. And, I put it back, or rather way back, I had this idea in my mind that I wanted to teach at IITM. So I planned this through. So for example, I never applied for my green card because I knew my long-term goal was to come back to IIT. So I got a lot of pressure from the company because everybody else was applying for a green card who joined with me. The lawyers called my manager asked me, hey, what's going on? And I kept putting it off. Because once you get the green card, you stay there, right? Because the permanent residency, it is easier, it makes your decision harder and so on. And it didn't make sense for me because I knew in a few years I would be coming back to India to teach here. So, I didn't even do that, for example. That is just an example to say it was a long-term thought in my mind.
You partially answered the next question, but still I'll go ahead. In your opinion, what is the difference between research in academia and research in a corporation?
Okay. Yeah, so I think that the previous answer covers it. I'll just say it is not that there is no role for research in companies, but what I would say is the idea is that there are very well-defined parameters in a company that will decide the direction of your research. You will of course be assigned the circuit that you are going to work on. Okay, you don't have that independence. Second thing, the product that you're going to put out they'll have a plan for the specifications, how it will fit in to the market, to the bigger system, etc. That will decide the specifications of your circuit, and finally we'll also decide the directions, how broad, how narrow you think, etc. So I would say from that point of view, it is highly constrained research in that sense. Now there are still some companies that have R&D labs inside companies. Qualcomm has a corporate R&D, Texas Instruments has Kilby labs, Intel has Circuits Research Lab. Many of the big companies have the small research divisions. They are very small, they don't expand a lot, they are looking at next generation circuits for next generation systems, but that is exactly what I want to do in an academic setting. Okay, so I would say except you patent in the company, here you publish.
Next question is, what advice would you give a PhD student who is stuck? What kept you constantly motivated throughout your PhD?
Okay, very good question.
Can I add on to that?
Sure.
Is there any lowest point that every time you felt doing your PhD, and how did you go through that?
Okay, yes. So I'll talk about each and everything. So let's first start. First question was about the being stuck in the PhD. Okay. See, being stuck in the PhD at some point of time, typically after a couple of 2-3 years, is extremely common. Okay, it is much more common than you might think. And I would say my advice, if you are ever in that situation, is to take very close guidance from your advisor, because they have most likely gone through the same thing and they have tackled it. That is the number one thing that you can do. Okay? What I would advise you not to do is drop out of your PhD. Never do that just because you are feeling low, that you have not made any progress, etc. Okay? Because a lot of research is just keeping at it. Okay? Sometimes for some people, lucky, the idea, the progress occurs early on. For some people it occurs late. Okay? But you need to give it time. Okay? And the one thing I will tell you is, you need to be thinking about the problem all the time. Okay. I have had ideas while on long drives, and I know people. I've had ideas in many situations that you are not. You have some space to think, but it will be like I know people who have been traveling on a train journey. Suddenly they get an idea, they look around for a piece of paper to jot down their idea before they, or one of my somebody I know, they told me that while showering one day during their PhD, suddenly they got an idea that led to a major paper. Okay, you can imagine the diversity of places. It's because they are thinking about the problems all the time. If you are feeling low, you are definitely going to come out of it. Don't drop out. I would strongly advise against that. Reach out to your advisor. Okay, they will help you because they have the experience of undergoing that experience. That much I will say. Okay, very important. And the PhD guide is also an expert. They would have had other students who have most likely undergone such lows. They know what works, what doesn't. That is also another good thing. And finally, one thing I'll tell you. Many of the reasons for feeling low, etc. There are several classic reasons. When you go into your PhD, one person described to me like this. So you enter the PhD thinking that you're going to. He gave the example in terms of an animal. You're going to build an elephant. In the end, what actually comes out is a mouse. Okay, and very likely you go with grand plans, saying that I'm going to hit a sixer, change the world, etc. Unfortunately, there are very few areas of research where this is possible. Okay, and this really happens. Okay, there are some areas where it happens. Believe me, even in EE, VLSI, some students are lucky enough to hit that. Right place, right time, right student, right advisor. Everything needs to come. The stars need to align for that to happen, right? But in general case, what that person said about the elephant and the mouse is most likely true. You go in with grand plans, slowly it gets whittled down. The advisor does some whittling down, you yourself do some whittling down, and finally what comes out is a perfect mouse, but it's a mouse that you built by yourself. Okay, that's what I mean. It is still an achievement, it's a great achievement, there is a place for it. Okay? So, lot of the low point that you hit is because of the mismatch between the progress and what you had planned out 2 years ago, 3 years ago in your own mind. Okay? It need not be so. That is why I'm saying reach out to your advisor. They will explain all of this to you. They will, tell you. If you're part of a bigger group, you yourself might realize this, because you'll see other students going through the same things, right? So you will see that they had this. See, because you will see the group meetings, presentations. They planned some grand thing. What came out was some small thing. You will realize that for many people it's like that, right?
Next question is how you
Sorry, what was your question?
Was there any low point in your?
Okay, I think I didn't answer that. I don't think there was any explicit majorly low point. Okay. My PhD also, my PhD advisor was also open enough to let me set the path. Okay, let me kind of define the parameters, what I'm going to do, what timeline I'm going to follow, etc. I don't think there is any true low point is when you miss a tape out. When you miss an IC tape out, the next one comes 3 months later because you have just lost 3 months. Okay, it is a low point, but you'll come out of it fairly quickly. Okay, nowadays tape outs are much more common. In those days, it'd be once every 3-4 months. In those days, you would tape out much larger chips, put 2-3 PhD students' chips together and tape out the chip. And if you don't make it, they also don't make it. Okay, so I would say there was one situation where that happened. I just didn't have the confidence that I had done enough, and stop the tape out, right? We taped out 3 months later, and there was no problem, right? That was probably the lowest point. Otherwise, there were no true low points.
Sorry, what is tape out?
Good question. See, IC design, integrated circuit design, what you do is you design the circuit, maybe by hand, maybe conceptualize the circuit, analyze it by hand, then you design it using the simulator, a circuit simulator. Then you actually have to draw the circuit because the devices, it goes to a semiconductor foundry to be fabricated. They are basically going to say, what are the dimensions of this layer, that layer, etc. So you have to translate your circuit to that particular information that the foundry can use to build the integrated circuit. The integrated circuit foundry requires only geometric information. Okay, what you do is translate your devices that you have designed with into geometric information, which is called a layout. You have to send it. The process of fabricating the integrated circuit by the foundry is about 2 to 3 months, 4 months long. It takes that much time. So you are sending the file, okay, to those people with this layout information. Is called a tape out. Most likely because in olden days it would go by magnetic tape, right? You would not be uploading files. You would these are days. See, because it may be like maybe in those days hundreds of megabytes of information. You don't have hard disks that are that big. Most likely magnetic tapes. You will mail it to them, to the foundry. The foundry would read it from the magnetic tape, and that's why it most likely it's called a tape.
Next question, have your research interests changed over time?
Definitely they have. So for example, during my grad studies, I did a lot of work on VCOs, PLLs. Now after joining IIT, I am doing a lot of work on the RF core, signal path, transmitters, receivers. I'm working less on PLLs, nowadays. For example, I told you I was very interested in biology, right? So I had a master student work on an ECG IC, for example. Okay, so that is complete. That's the first and so far last work in that area. Okay, but it is just suddenly got one idea from communication circuits that could be applied to ECG readout circuits. They are operating, communication circuits are operating gigahertz, that is operating at hertz. Okay, so from about 50 millihertz to 200 hertz is the typical content of an ECG signal. But we built it anyways. We applied this thing, it worked. We did it, we published it, and after that nothing has happened. Okay, and the second thing I would say is, working in IIT, I'm seeing the research going on in many other fields. Definitely, a lot of interesting collaborations across groups. For example, little bit with the photonics group, little bit with the devices group, and so on, right? So that is happening. So definitely, the areas of research are broadening. Definitely.
So I think now we have completed the technical questions. There are a few other questions that go to what skill is the most useful one for BTech students to get into master's/PhD program of their choice to the CGPA/publication. Please compare with what you felt it was like when you graduated.
Okay. So when we graduated, internships, publications, etc. were not even a thing. Okay. There were literally only 2 metrics: CGPA, GRE score. TOEFL was the requirement, but anybody with a decent knowledge of TOEFL would get, it was seen as a requirement. You would get a certain minimum and you're done, right? So GRE mattered, but primarily CGPA. Okay, and what courses you have done. Probably those parameters have widened, but my own gut feeling, if you talk to the professor, the program might filter you based on many things, but most likely, if you talk to the professor whom you are applying to for PhD, they will most likely tell you your publications don't matter. They will most likely tell you internships don't matter that much, unless you have done an internship with them or with another university research group, then it matters. You understand? If you have gone and worked in a company and all, they don't see it as a, see, if I have 2 people with the same CGPA, then that will tip the scales. But if another person had a better CGPA, it just shows that he studied the undergrad subjects better. Most likely they will go with that. This is my gut feeling as a teacher. And as a person who looks at PhD students, MS students, B.Tech students. My own gut feeling is that most professors whom you apply to, USA, Europe, other places, they primarily are interested in your CGPA, in your fundamentals. Everything else can be built on. You can build on everything else. Your basic sciences, basic engineering, if they are solid, you can pick up everything else. What is the specific skill that you learn during an internship that can be useful for a PhD? Probably not, or maybe some application. Or see, the problem is at the undergrad level, if you do an internship, you will never get to the point, they will never give you that much responsibility that you will actually find something really useful. Okay, maybe you are forced to learn coding and that help you, maybe some particular, or maybe you are forced to run simulations that might help you, ancillary things. They are always things that you will learn. Okay, same way, publications. If it is a solid publication in a solid conference or a journal, it will have a lot of value. Definitely, I can imagine that. If it is some chota mota conference, my gut feeling is it won't matter. Okay, this is my gut feeling. If it is a standard conference, then it will definitely matter, right? If you do it in some random, see, the problem is there are so many conferences now. It may be hard for the professor to judge whether it's a good conference or a not so good conference. If it is in their area, they will know. If it is in somebody else's area, they may not know. This is the real issue. That is why I strongly suspect CGPA plus GRE is probably the primary metric that they will use.
Now we have two last interesting questions. What differences do you see between an undergraduate now and an undergraduate back initially?
Okay, I think I covered some aspects, right? I told you in terms of being how busy you folks are, right? Very different. So one thing I would say is that maybe because of this, maybe because of other things, definitely the undergrads today seem less social than when we were, right? On the average, I'm not saying everybody is like that. On the average, I somehow feel we had quiet ones, we had people who would never speak, right? I have had classmates in EE with whom I have spoken, a few words a year, over 4 years each year. And I have had classmates whom very close friends of mine even now, and so on. Wide spectrum. But on the average, we were definitely much more social. That made a big impact to many things. It made a big impact on how happy we were, how stressed out or not so stressed out we were. It made a big this thing on whom we can reach out to, right? I mean, if you need something, and some of the friends that you make today will be friends for many, many years to come. Okay, and there is a much wider group if you are more social, right? And I'm worried that the groups are smaller and people are also less social than they used to be. It's probably you folks to tell me if what I'm saying is not true, my impression about you folks, because I've not been a warden, so I wouldn't know how social you folks are in the hostel, but this is my gut feeling. Okay, this is one big difference. Second, and I talked about this busyness. I would say not much more. Okay, the interests we had were very different from yours, but that's natural, right? One thing is, I find that you folks are much more tied to phones and laptop computers and so on than we are. At least many of you. I see my colleagues. Well, maybe because you said analog circuits is like a huge scary thing for all of you. I didn't see a lot of laptops in my class, only 1 or 2. But other professors tell me that there are a lot of laptops open, phones open in their class. That's not a good sign. Okay, so that is a big difference. Okay, in our it leads to a lack of focus, and I see it in myself. I'm not saying this. Now that I have a phone, I see a lack of focus, right? Of a feeling of being tied to the phone. It exists for everybody, including us. Okay, it's a worrying trend for all of us, not just for you, right? So I would strongly advise, right, that we should all kind of remove the tether to our digital devices, at least for a few hours a day, right? That's what I would say.
Stay in the analog world.
Stay in the analog world, I like that. So that reminds me, so when I first started grad school, my professor was of course analog and RF professor. In those, I joined grad school in 2000. I don't know how many of you know, US elections, there was a president called George Bush, okay? And the person who fought the election against him was a guy called Al Gore, okay? And the US, they have this style of debates, political debates. And apparently in one of the debates, if I remember right, I think George Bush, called Al Gore an analog person in a digital world. Okay, and my prof was really pissed off. Okay, I can tell you. So what you said about being, away from digital devices in the analog world makes a lot of sense. Okay.
The final question, your take on the future of core electrical engineering.
Oh, okay.
Is there a core now? Everything is.
So it depends on what you call a core. Okay. See, electrical engineering has always been a very broad area, and everything from physics, chemistry, material science, computer science, mechanical controls, there is overlap with almost all different areas of electrical engineering. Okay. By the way, I am trying to see if there is some application of electrical engineering. We are talking to a civil engineering professor to see if there is something that we can do. Okay, very interesting. It's a very broad area. There are very few broad areas in engineering, very few areas that are as broad as EE. So when you say core EE, it is very hard to define. Okay, it changes with every generation. If you go even 20-30 years before in the 70s, okay, core EE would have been, electronics was in its infancy. Okay, core EE would have been transformers, machines, power systems, and so on. The next generation was power electronics. The next generation was, devices, communication, so on, right? Then IC design, and not all of these can be called as core areas of electrical engineering.
Now where is it trending?
So, I would say the beauty is, there is, interesting things to do, employment in every one of these areas in today's world. That is the amazing thing. You go back 20 years, there were only a few areas where you would actually find employment easily. Okay, now you can find great employment, very interesting things to do in every one of these areas. Okay, so I would say you should go with your passion. What do you like? Okay, the beauty is that now that there is space for everybody to do what they like to do, that's like amazing. Okay, you prefer electrical vehicles, do work on electrical vehicles, be the best in that. You like communication, there is still space. 5G is there, 6G is going to come, hopefully 7G, 8G, 9G will be there, right? You like signal processing, yeah, sure, speech, image, video, all these things, processing is all going to be there. You like a circuit design, 100% IC design is going to be with us for a long time, in some form or the other. You like devices, yeah, people are going to keep building devices, right? You like microwave, EM fields, photonics, things like that. Yes, of course, these things are going to be with us for a long time, right? That is the beauty of being in such a broad area. You will find something that you like, you should do that which you like. Now, I'll end by saying that what you are going to be doing, you folks are going to be doing 5-10 years from now, even if you do IC design, is going to be somewhat different from what we are doing. Okay, for example, I can say with respect to IC design, I know all of you folks want to do something in AI, ML, etc. But it's only a matter of time before it comes to design, circuit design in some form. Okay, what form it is, I don't know. what I do know from talking to the community, people are looking at various aspects already for circuit design, for designing, for automating many different things. Okay, indeed they are looking at it. Okay, oldies no, right? The people who are well established in the field, they may not necessarily be looking at it, but the people who are really working in various areas, they are looking at it, and that is probably going to transform every area. This is my gut feeling, in some way or the other. Okay, typically in the next 10, 15, 20 years, I expect it to come in an applied form. For circuit design, it could be in the form of tools to assist the way you do design, assist the way you do tape out. Okay, I don't expect this design to come up with new circuits. I don't expect an ML system to come up with new ways of doing signal processing, but it will take care of all the old ways. You come up with a new way, it will take care of that, right? Same thing for I don't expect it to come with a new device, but if you ask it to figure out something unknown about a new device, it very well probably might, right? It may not know how to design a new power system or a new electrical vehicle or a new battery, but if you tell it to assist you in designing it, 100% we are not far away from that. This is my belief, right? So I would strongly urge all of you to think about it. Maybe you are at the stage where you probably at least want to learn. Don't close yourself off to many of these techniques. It is just a technique. Linear algebra, machine learning, doing courses in that, it's a tool. Right? Just like any other mathematical tool, it's a tool that will most likely, many of you, if you remain in EE, you will like it. And really, EE is nowhere close to going away from our lives, right? In all aspects of our lives, right? Every aspect of EE. You are still going to require power. Maybe it's from renewable sources, right? You are still going to drive vehicles, electric vehicles, which will require batteries. You are going to use some device which is going to have electronics. It's going to have digital, it's going to have analog. It's going to communicate, right? You are going to need to build those devices. You are going to need, photonic systems in many different ways, right? And so on and so forth for every different area. Okay, so I would say, core area, core EE, definitely is going to be with us for a long, long time. In fact, I can't imagine, right, our lives without EE in some form, and EE being an area which is of interest to many people, right, for a long time to come, I would say.
If you have formally completed all the questions, then thank you for your time.
Sure.